Okay, so I think that particle robots are pretty cool. I don't know about you guys, but like right now in that video, they look pretty big. But if we were able to shrink it down into like the nano scale, maybe it's possible to get these robots into our bodies to help deliver drugs. So like how that video was mentioning, the particle robots are capable of moving through unfamiliar environments, suggesting that they could still be useful even if we put them into a biological setting where it's unfamiliar to them. So they can be self-healed and they are robust even if some of the particles are non-functioning. So this could be an advantage in the harsh biological conditions. If it happens to get damaged, it could fix itself, or even if it can't, it could still function reasonably well. So I think that's pretty useful. As well, if we integrate particle robots with some AI algorithms, we could make this into a very, very powerful tool in delivering nanoparticles to treat specific sites in the body. This might not even be limited to just diseases, but like how the video suggested, like maybe even repairing things in your body in a less invasive way compared to like open surgery or something. So, of course, as we've talked about throughout the course, new technologies will bring about ethical issues that need to be discussed. So from some surveys, overall, most people are nervous about AI and unfriendly AI, but in this case, in healthcare, there's also the problem of security, privacy, and protection of sensitive information. Since AI will require data sourcing, data mining, and big data to gather enough information to make predictive models, people might be scared and less willing to be accepting of this idea of giving up all of their information. To combat this, I think it's necessary for people providing these new technological services to adhere to specific guidelines regarding the privacy and protection of information and transparency with what the information is used for. As well, from these predictive models, especially those that are made from black box algorithms, where we can't actually see the process of how the machine gets its outputs, it runs the risk of what happens if the model isn't fair to a certain group of people. In this case, though a black box method might be more powerful, we might have to revert back to a method that is more transparent and editable by the researcher to correct for the biases. Lastly, these technologies may come at a high cost at first. So it brings the question of whether the people who need this technology will even be able to afford it, and whether this will become a universal healthcare standard or only a luxury for a select few. I personally hope that it's going to become a standard because I think it's pretty cool, but I'm not sure, so we'll see what the future brings. So to conclude, before we've talked about the conceptual shift in medicine, and the idea that the role of physicians in the future will be more about enhancing patients' lives instead of curing diseases. So this raises the question of whether these new technologies in AI and nanobiotechnology will, for drug development, will be phased out alongside diseases or not. Personally, I don't think this will happen just because these technologies can easily be switched from delivering drugs that cure diseases to drugs that could enhance our biology. So we could be delivering nanomaterials within our bodies to carry out enhancements, or even deliver drugs that cause the enhancements themselves. Or even what I've mentioned before, maybe nanoparticle robots in the future will be the ones carrying out less invasive internal surgeries to enhance our biology. So I think there will be many uses for these technologies in the future of personalized medicine. And yeah, that concludes my any questions?
So there's some really kind of amusing history in this course about someone that you know very well. Jack Tazinski, the first semester that you taught in the course, promised to talk about quantum biology and did a kind of bait and switch where he hadn't really done a lecture before. It was just something he thought he could do on that subject. But he talks about your subject all the time, computational drug design. So he just took the slides from his standard talk on computational drug design and gave it for this course. I was so mad. You haven't seen me mad very often, but this was like an offense because we were looking forward to hearing about quantum biology. But I also realized this is his day job. It's his main function, and it's a very important job right now. Quantum biology is very exciting for the future, but computational drug design is a huge and very important topic. So now he has learned in this course that he can't talk about this, and he has to talk about quantum biology, but that gives you sort of more of an opportunity. So there will probably be an evolution of how medicine works, where the standard, thinking of how many pills you have to take every how many hours, there'll be very few things that we treat like that in the long run. But even these newer drugs, like if you're infusing something all the time, there are a whole host of things. Maybe you're not giving it into blood vessels, but having it absorbed through the skin. There's all sorts of interesting advances there. So other questions? Yeah.
So in one part of your talk, you really talked about like how this AI can really help healthcare, and the app that you're talking about that visualizes someone ingested their medicine and stuff. So you went from this very heavy AI focus to this very, I guess, basic focus with like basic science and the particle robots, right, and how those can be miniaturized and be used in humans, right? So I guess, how important do you think like AI actually will be in the future of medicine, or do you think more simple, I guess, bio-inspired designs such as the particle robots will be more predominant and more cost-effective or something like that?
I think AI will be pretty important. Like, I think we could, like, instead of just thinking about them like separately, like just like the particle robots by itself and like the AI and stuff, like, although it said, like in the video they said that they don't need like complex algorithms or anything like that, I think like maybe like if they did integrate like AI algorithms or something like that, like it could like even enhance it even more, and it could do like even like cooler things and stuff like that. So yeah, like I think like, yeah, it'll be like pretty important in medicine in the future and stuff. So
to add on to that, totally agree with you, because we were talking about in the video like the nanobot things, right? They can navigate in spaces that they've never like navigated in before. So what if they could like remember and learn from that instead of just every time it's like a new thing, right? So yeah.
I was wondering, in your research, are any of these nanotechnologies in medicine being tested right now in like animals or humans, or is it mostly theoretical at this point?
like the robots,
Yeah.
I didn't read anything about like in like humans or anything. Like the most they have is like nanomedicine and like the nanoparticles. So like the example I gave with like the ligand and like having like more specificity to like getting to its target and stuff like that. But
Yeah.
yeah, I didn't read anything about the robots being used. actual like animals. or
Yeah.
anything. Yeah.
Okay.
Okay, I think we should move on now. Thank you.